My name is Kostiantyn. I'm hardware engineer at Sensario, and today I want to talk about smart homes. I think a lot of you heard about smart houses, connected houses. Some of you may have one. No? Nobody? Did anybody try to do one? Okay. It's a very interesting process. If you start, you will never stop. Yeah. So let's talk about myself a little bit. I come from Ukraine. I've been in Norway for 2 years. I now work with sensor networks. I design hardware to have wireless sensors around Norway. I help with avalanches, with railways. We have a project where we will have a signal to stop trains 30 seconds before the avalanche comes. So that's what I do. But my hobby is smart home. It started as a necessity, then it became a hobby, and now it's a passion. So, yeah. Your house is your stronghold. When I started first, I had a problem back at home with heating. I think it's the most common problem in all the smart houses, lights and heating. I designed a small network of temperature sensors and have some air blasters that turned on and off heating or cooling, depends on the season. It worked well. I had a lot of bugs, and it took me, I think, 2 months to actually go and get it all running properly. I used a lot of open software. I'm not a programmer. I'm not very good with software, but I tried and it worked. Yeah. So, sorry. After some time, I started thinking about what if I can do some kind of system that will be available to everyone, and everybody will install it at their houses, and then after I get data about myself and deliver it to them, I will get the same principle. So I will have my temperature, same maybe heating in the floor, maybe same lights if they have the same system or close to it. And I started thinking about smart homes. Well, the concept of smart home is a little bit different from smart houses, because smart houses, in my opinion, is just the connected house where you have light bulbs connected to internet. You can use your phone to switch it on and off, and basically that's it. Smart home is a complex system where it learns about you, how you behave, what you use, and in the end, I want it to be smart enough or to be able to be intelligent enough to understand what I would like my surrounding to be. So for example, if I come home and it knows from previous information what I did outside of the house, it will guess what type of environment I want to be in now. That's a crazy idea, but I'm trying and working on it, and I hope at some point I will deliver something. Options. Before I start talking about my system, I want to talk about options of smart houses or smart home solutions that are available now. Most of them open source. I try to use open source software because, well, I can download it easily and dig inside of it. But a lot of people thought that they might get away with complex industrial solutions just translated into a home environment. So came OpenHub. OpenHub is a Java-based platform for a smart home. It has a lot of plugins, so you can connect different hardware to it. I don't think it's a very good solution because it's Java-based and it's not very good for embedded solutions. Most people won't install a huge rack with a lot of servers to run their smart home. They would do something very small, and Java is not very good at that. At least in my experience, I ran it for half a year. No, I ran out of memory. That was my problem. Next one, Home Assistant. It's a Python-based system, open sourced. It's very new. Not a lot of modules available, but you can hack it, and it's Python-based, so it's lightweight, fast, and it's quite scalable. OpenHub is not that scalable if you want to have a lot of small nodes in your home network. Another one is Eclipse Smart Home. It's actually not a full solution, it's more of a design concept. Eclipse started this project to gather all the knowledge from around the world and maybe come up with some kind of proper solution, but now it's just assembly of different projects in one place. Yeah. And another one is Jarvis. Like Iron Man's Jarvis, it can talk, it has a pretty interface. I used it for a couple of weeks. I wasn't that satisfied, but it's really fun. Right now, actually testing the Home Assist, and I like it. It's been running for almost a year now, and I didn't have many pictures. Yeah. So, and of course there are many more, and you can do your own. Try assemble different parts, make it yours, brew it yourself. Now I would like to talk about my system. This is the brain from 2015, middle 2015. My home started with a couple of Nexa switches and Telstick net device. I bought it at Olsen. It costed me 1,000 kroners to help with heating as well. When I moved to Norway, I had a problem of paying too much for electricity, and now I pay half as much as I did before. But now this brain is used for much more. For smart home, I use neural networks to analyze my behavior, my wife's behavior, how we use our home each day, every day, and we try to get feedback. We don't actually allow it to control our home, we just use it to learn. One example, actually a couple of weeks ago, we prevented a fire at our house. We had a failure at our electrical network, and we prevented the house with this system. It just told us that we had overheating in the electrical box, and we just shut everything down, and we didn't have fire. But we had smoke. It smelled quite a lot. So it's useful. It's running on 3 Raspberry Pis. It's a cluster. You can reconfigure it automatically. It actually can do it itself. I tried it once, but never did it after that. It takes a lot of time, and I'm not good with the software, so sorry. Yeah, sometimes I try to do things very pretty, like this. It's our artificial window. It was a small project, started from 2 doors for it started as a project of 2 doors from IKEA for kitchen. I bought it for 10 kronos each, and my wife decided to paint them. She painted them, and we thought, hey, why won't we add some LEDs and some Wi-Fi to it and see what happens. Now when the sun goes down, this thing wakes up and we have more light, or at least a little bit more sun till the end of the day when we come back home. So sometimes you can make it very, very nice, but of course you need someone to actually help it make it nice. I cannot do nice things, I do this. This is typical projects at my home. If I have time, I design these things. I'm good at hardware, not pretty hardware, but at hardware. And it's fine. If you try and do stuff yourself, it will look like that, maybe better. If you're very, if you're really good in designing stuff, you will make it better, I think, but it's nice when you just do it and don't think about the design. Just make it work, try. Failures will come all the time, it's fine, and smart homes work from small pieces. It's actually really, really hard to have a finished system design from ground up. Yeah. Big companies. That's one of the topics I think you'll touch if you work with Linux. When big companies touch Linux, they sometimes create something very complex and unreliable, or that needs a lot of support, and frustration comes. At least for me, all the industrial Linux was like that. Very frustrating. So don't trust big names. It's very young field. the smart homes. Try, but don't just trust them. I trusted one house and it didn't work. And I'm actually very scared about both systems. And if it's open, I can touch it, I can check it, everybody else can check it. Collaboration will help us make it better. Don't trust the closed ones. Yeah, that's my motto, be open. I try to use open stuff and I'm trying to give away. I share most of the stuff on GitHub and Instructables. I have a couple of Instructables now on SmartHomes. And it pays out. People comment and I get feedback about what I do right, what I do wrong on hardware, software, and my house becomes better and better with all those comments. And it was very nice when I first started doing this, not knowing a lot about software, to come and ask people or internet give me some advice and find a lot of small examples for different solutions and combine them and come up with a very nice system in the end. And I'm very grateful to all the people who shared their stuff, and I hope that if you would like to start with Smart House project, you will be grateful for that and will share as much as you can. Connected house. It's very important to understand, as I said before, a connected house and smart home are very different things. Connected house is the foundation of what you will build later, but my main goal in the smart home is to actually deliver that smartness where it will predict what you expect from it. And building a smart house is not really hard. You can start with a couple of small pieces of hardware and a couple of lines of code and you're done. You can have a lot of switches at your house. Is the basic hello world for smart houses. Turn on and off your light. And it's really fun and very useful. Then you can go to heating. It's not very complex and you can design things around your existing heaters or switch to it to some more sophisticated stuff, but you can imagine what you can do while you're doing it. For me, it was the same experience of starting with something small, then seeing potential and going further, seeing more potential, going further, and you cannot stop. I reiterate my system each month, I think. I find something new, some small pieces that I can develop more or find a previous solution, and it's very, very interesting process of making your home nicer. Actually, Norwegian has a very nice word to it, husly. It's one of the first words I actually learned in Norway, and it means it's cozy, but it's much, much better. At least what I understand from that word. And that's what I'm trying to achieve husly by making my home feel what I want from it. Make it hardware, that's what I do best, and I'm trying to do it. This is the design of the first system I had. This is just Raspberry Pi and a couple of temperature sensors. It's cheap and you can build it in half an hour. It's 10 lines of code in Python, and you have temperature monitoring in your house. It's simple. You can give it a web interface and you can monitor temperature at your home and know maybe there are problems in your house. And I know that in my house it was like that. We had a lot of leakage and now it's fixed, so it helps. This is current-ish setup. So you see I reiterated quite a lot. I added a lot of stuff. I've got 4 Raspberry Pis, now it's actually 7. I added more in January. I have separate Wi-Fi network for it. I don't trust going online just like that. My wife is a security engineer, and she designs special security system for it to go outside when we actually need it. Yeah. So I based on what I can buy off the shelf. I didn't design any special hardware for it, at least not now. And this is how you can build your house. If anybody is interested, I think this design is not shared yet, but I will share it on GitHub, and please take it and try it. It's quite simple, the code is very, very simple, and yeah, you can build it and make your home more comfortable. Or at least, I hope it will make your home comfortable. And at some point, maybe I get to visit you and I send you my home, and I feel at home at your home. At least that's my vision. Make it software. If anybody wants to join this project, please join me, because I'm very bad at software, and if you're great at software, please share your ideas and thoughts on what you can make, or you make your contribution to this project, because I need somebody who actually understands software. I have a couple of people who volunteered to help me with neural networks, because that's very complex stuff for me. And I like when people just comment something and it really works. So it's very important to make it software as well. It's always collaboration of hardware and software. You cannot make it either way. You have to mix them all the time. Energy efficiency. It's one of the critical things for me. I like to be very energy efficient. And when you design some kind of system in your house, you want to save electricity as much as possible. So smart house or smart home has in its goal save your money in the end, and doing it by being very, very energy efficient. So my example is that self-assembled small system helped me save half of money that I paid for electricity. It was very surprising for me and people around me. They didn't believe me, and for last 2 years we've been monitoring and comparing. We actually save half of the energy we would have used before. So adding a little bit smart to your house helps save your money, and this is not very expensive. Doing this actually not that expensive as smart things or some other industrial solution that you can buy now. You start with something very, very small. So buy Arduino, buy a couple of relays, build your first small brick, make it a little bit smart, and then you will be interested enough to build another brick, make it smart, build another one, and then you build a smart home. And in the end, yes, I want to build a home that will be able to predict what I like and share it to other people, so when I come to visit them, I will feel myself at home at their home, which is really, really nice. Sometimes you start with something small and it's really nice. Do it, it's simple, but don't go like that. Sometimes you have too much fun and you go over the head, and it's great when you are very excited and you have a lot of energy, but overdoing it is also very, very bad. You lose your vision and you don't feel that you achieved something in the end, because it's too much wires and it doesn't do anything. Yep, and in the end it's all about the fun. I like doing this. I have a lot of fun doing this when I have free time now, less time than before, but I still enjoy those 2 hours that I can spend on my smart home and develop it a little bit more, add a couple of lines of code or one bit of hardware that will make it stronger or make it a little bit more smarter. And you can do it too. It's really simple, and please join this movement. Make your home smart. Yep. So thank you very much. This is my small presentation. If you have any questions, because I didn't prepare for a very long presentation, but I have a lot of things to share, and if you have any questions, I can share. Yeah.
You said your system learns somehow. What does it learn, and kind of what is the input? You probably have temperature sensors, but how do you, is it, for instance, what do you try to learn?
Basically, right now we're trying to learn patterns. So from temperature you can get a lot of data. When you move around your house, you change your temperature footprint, and from that you can learn where people are. I don't know about Norwegian culture of staying at home, but at my home, and I think most people in Ukraine, they tend to be in one space. So you have a lot of rooms. From temperature footprint, you can actually guess where the people are. So I'm trying to learn that. With switching on and off lights, you can guess which lights are used more. So we learn which light bulbs we try to predict which light bulbs will go off first. We have one potential candidate in 3 or 4 months, I think. So I will share online if it actually works. My friend, she suggested that you can actually learn a little bit more from how you use your entrance door and the doors inside. We try to use movement. We have a couple of test movement sensors on the doors. So we try to predict when you open the door from inside the room or outside the room. That's one of the patterns that we are trying to learn. It's actually working just a little bit, but maybe in a couple of months we can learn more. So those patterns we try to learn, and from that we maybe will be able to extrapolate what your movements in the apartment are, what would you prefer from day to day. We're not sure. It's for me it's a very complex question, and I cannot answer to that. But that's what I'm trying to learn now. Those are the goals. Yeah.
Have you tried using sound to detect where you are?
Sound? No, not yet. If anybody can join on that project, I would gladly test it at my house. No problem, but no, we didn't try sound yet. Yeah.
Can you tell us a little bit about what hardware you need to be able to, for instance, turn off and on like ovens, and what kind of hardware you need for doing temperature readings and stuff like that?
Yeah.
Do you have any schematics or anything that would show that actually shows how you built this stuff?
Yeah. I have. I think I need to start sharing this more and more because I was a little bit chaotic in what I actually shared. This is just standard Raspberry Pi. This was the old version B, and it's Dallas's temperature sensors. They use one wire bus, and they were just connected with standard wires. And I used telephone lines in the house to connect. This is the simplest option you can get. With this, it's a little bit more complex. Those on the top are ESP8266 with the same temperature sensor. I like it, and it's very, very cheap. It's in volume, it's like 10 kroners each. And ESP uses Wi-Fi to connect to your network. I use just standard router to assemble them in my private network and connect them to Raspberry Pis. On the Raspberry Pi side, different solutions. I use MQTT as the messaging protocol to assemble data from my network. That's the main protocol that is used in the house now. There are alternatives like co-op, but for my solution, it's a little bit too client-oriented, I think. It's in this solution you can have subscriptions to messages. In co-op you actually have routing system where you communicate between nodes and not have a centralized server. I actually wanted to switch from a centralized server to a distributed system, and I tried to have a couple of Raspberry Pis switching and changing master roles. So when one is down, the other one will pick up and switch it and become the master. I'm not that good with the software. So, but it's possible. I heard people do that. Yeah.
How many Raspberries do you use?
Right now it's 7. This setup has 4, but I've upgraded my system in January. Maybe-
Are they working together, or is it?
They are a cluster, so they are deployed with Ansible, and they are over network provision. So I have a small network installation. So if I want to redeploy my OS, it just I say redeploy with this configuration. It doesn't work. So I have a small caching DNS at home, and I cache Debian repository at home because redeploying 7 Raspberry Pis over the network all the time is a mess. It's like 1 gig of data for each, which is not good. Yeah.
How do you interact with high voltage appliances?
High voltage appliances. It's an interesting question. I never actually tried to control my oven. I used only heaters, and heaters are really simple because they are connected through outlets. So I have small outlets with it was previously Nexa outlets, but I changed them to my own solution with ESP8266 inside. So it's just a relay that can control up to 400 volts, and depending on how powerful my heating is, I just choose the correct relay. So from 3 amps to 10 amps, depending on which one I use. That's in most cases you use relays. For something that is very, very powerful, you try and use relays. There are no other nice solution to it. Variacs, you can use them, but more heat and you lose energy. Yeah, so it's the most efficient solution, at least for now. Yeah, I want to mention that right now I have one small network at home that is not connected to this, but it's going to be there. It's from work. We designed the sensor network, so I try that thing at home, but it's mostly for movements as well. So, it's Texas's technology. It's their chip, and it uses 868 megahertz radio, and uses 6LoWPAN. It's IPv6 network to have a mesh. That's my goal, actually, to have all the nodes in the house meshed. Yeah.
You mentioned 50% reduction of your power bill.
Yeah.
How high was your power bill before, and what were the main
Reasons?
effects which you saw
Uh,
save money at the end?
I first saw this with heating in February 2014. We got 1,500 kroners bill for heating. And the problem was that my wife, she likes the house to be a little bit warmer than I do. And she turned on all the heaters, and they stayed on all the time. And that's not actually smart. What I added is the switches, so we turned off and on heaters when we were not home. And I added convection, so I added fans to the heaters, and we started moving air in the house. And those are 2 main reasons why we got the cut in the bill. I'm lying a little bit that we get 50% all the time. It's not that, because you use heating less in the summer, but not that much, because in Norway it's, well, not that much difference. So it's 50, 55 during winter and something like 30 in summer, but it's relative, of course. Still, you achieve something. If you have a nice apartment or a house that had that system already installed, or people thought about it, you may not see such a big of a difference. But in old house from 60s or 70s that didn't have a proper convection system installed in the house, you will gain something, because it will be, you don't spend, well, most people don't spend 24 hours a day in the house. So you can at least be smart about when you turn on and off your heating. Yeah?
Do you have any thoughts about using one centralized unit, and what would the implications be if you were to?
I'm trying not to use centralized solutions. I started with one, but after that I tried to move to distributed one. Power failure. That's the main reason why I try not to think about centralized solutions. MQTT is one of the main stoppers for the distributed thing for me. But if I can achieve that, sure, I will have distributed thing and changing the roles because I know how to do that. Yeah.
Question from the internet.
Mm-hmm.
How long is the response time for the system, and how often is the made to make changes to the system?
Well, as I said, I don't use it to control my system now. We had simulations, but that's it. Response time, depending on the application. For light, it's very fast. So, for example, I turn on the light when we come home. We go around the house, and when I come to the house, I just press a button on the phone to turn on the lights. They turn on when we go around it, so it's really fast. And I have actually one of the things that I never tell, but I need to start telling that try to build your systems redundant. I have wireless, but still low-level switches or remotes for my whole system. So if we lose internet or we lose Wi-Fi, we will still be able to turn on and off the lights in the house and heating because, well, your loved ones won't like when you have cold apartments. And one of the problems that I actually was solving with my own outlets is that if they lose connection to the hub or the master, they will turn on the heating. They will be at the level, so it's 19 degrees, but they will be on even if you lose connection. So at least you won't come to the cold apartment. We didn't test it yet, but we want to try to use the data about if we are at home or not to have that security system be a little bit more smart. For now, it's just that like that. If failure, turn heating on. Lights won't go up, but heating will go on. Yep. Yep.
Well, I was supposed to just ask about cats yet. How about stuff like controlling your cat door? Or,
Cat door. I had a friend who asked about that. He has a project now in process. He bought RFID reader. He wanted to have smart door that opens only for his cat.
You've got commercial solutions that do that, but they're not networked, so it's not much.
Yeah. I'm not sure how it's working. I don't have a cat, but as I understand, it's really hard. The problem is that those RFID readers need to be very close to the animal.
Yeah,
In the back.
yeah, they usually have chips on some of them. So.
Yeah, I think it's possible to do that if you add a tunnel. I never actually thought about it, but he said that he made an entrance for his cat quite interesting. He has a small house for the cat. When it's out, it stays there, and he has entrance through that house, and he has the RFID reader in the entrance of the house. So he knows when his cat is inside the house, that small cat house.
Well, of course, leading on some stuff like automatic cat feeding.
I've seen one system that's like $500 that does that, and smart toilet for cats as well. We considered buying a cat, and then we started calculating how much would it cost us to have all the smart things for the cats, and then we decided, no, maybe later. But yeah, of course you can do it. There are solutions online that people actually do it themselves. I've seen a couple of projects, but still, I think it's a more software-ish problem because it's really hard to. Hardware is not that complicated. It's software that you need to make work and understand that all things happen. But yeah, you can do it. Go online. There are a couple of instructables, I think, and a lot of projects online on GitHub. There are sources for that. So yeah.
How do you see the security around it? I mean, we know now that you can plug your wireless LAN and then we heat on your house, right, to make it like 100 degrees hot, and then it burns down because all the heaters are on. So
Yeah, security. Well, it's on this private network, so it's hidden. It's VPA2 secured. All the communication has its own keys. I actually don't know much about security in terms of software because my wife does that. She's really smart about it. So, yeah. The hardware part, it won't go up. The heating won't go up more than you expect it to go because in that box I have a temperature sensor as well. So if it goes to, I'm not sure, it's 27 I think degrees, it will show. So it will be smart until it has power. It will be smart. Of course, if you get no power, you won't have heating. So no problem with that. Yeah. Any more questions? Comments, suggestions, volunteers to do stuff? You can find me on my nickname Transcats on almost anything. So on GitHub, try look on my projects. I cleaned up a little bit, so not many projects there, but I will put them back as soon as I can. Yeah, and enjoy hacking your house. Yeah, there's a question.
How do you said you use Telstics?
Yeah, I started with Telstick.
Yeah. How do you find the APIs or how do you interface with the Telstick solution?
Oh, it's actually quite simple. They have opened the source for everything. So go to the Telstick, clone their Git repository, and you're golden. And they don't use something proprietary. It's standard for 3.3 megahertz radio and standard protocol, so you can actually have your own system up and running in no time. It just was faster to buy it because you need a solution.
So you can use a different hub.
Yeah, right now it's I disconnected their online service. If that's what you're asking, I disconnected it more than a year ago. And right now we have our own online access to it, so it's through the servers, but our servers.
So but you still use the Telstick Net.
Yeah, I use it because it's I reflash the firmware, but I use their box because it's it's there. I don't want to waste more money on buying 333 module to control it. But it's actually inside the Telstick there's not much. It's one PIC microcontroller, a couple of radio components for the front end, and Ethernet. That's
So
it.
out of the box, it depends on an online service
No.
outside of your own.
Well, when you buy it, yes. When you hack it, no.
Yeah, I mean, is so the out of the box solution is
Out of
is
the box,
basically
if you buy
dead if you don't have internet.
Yeah. If it's dead, if you don't have connection to their servers, it's dead. It cannot do much. Well, it can do anything at all. One thing that it can do a little bit, it can serve as a repeater for your remotes. That's the only thing that it can do. It will repeat the signal from that. But that's pretty much it. Inside the PIC controller, it's just the logic for APIs from Telnet.
You also mentioned big companies that maybe didn't have that much.
Yeah.
Do you know how the Osram or the Philips Hue
Work?
work?
Philips Hue is actually a fun and nice thing. If you buy them and just use them independently of anything, they're fine. APIs are messy, as I heard, and the one thing that can control it quite nice is the Amazon's Echo. So Alexa can control your Hue, but nothing else. SmartThings had integration with Hue, but now they broke something and it doesn't work. SmartThings, it's the thing that Samsung bought a year ago. It was an independent company. They had quite nice solution, but when Samsung bought them, they stopped developing modules for different APIs around the world. They try, but not so much. And I hear people complaining. There's a podcast Tested from Adam Savage, and it's their website, and they have podcast. And one of the people there. Smith, he has smart things, and he was complaining for a very long time that he lost his hue and he lost NAS integration and something else, so the smart home just fell apart. So that's why I don't trust them, because they're closed, and if they change something, you cannot react to it. When you change something on your own, you at least have your backups and you can roll back. When SmartThings or Hue update something, you usually cannot do rollback. Yeah. Okay. Yeah.
Have you looked at this instrument's smart tag?
Mm-hmm. Yeah. It's a very nice box.
Sensor tag.
Sensor tag. Yeah. It's 2650 CC 2650. It's a very nice chip. It's 2.4 gigahertz. I actually use it at work. Nice platform to hack. You can have a lot of different solutions or systems built around that. You can have mesh networks. It's very cheap comparing to what you can get for that money. So if you want to try it, buy one. Buy the debug module as well, because connecting wires to the sensor tag is it's a mess. And I soldered quite a lot in my life. I would never try to solder wires to sensor tag. It's too complicated. So just buy that debug module. You will be fine. Yeah. Anyone else? Yeah. I think we're done. So thank you for coming and listening. And yeah, I heard a lot of nice questions. I actually will think a bit, because I found a couple of ideas while talking. Thank you very much for talking with me.